Okay, so we begin with a particle of mass m, and that particle, we know from Newton's second law that the acceleration on this particle is going to be equal to 1 over the mass of the object times the net force on the object. So if F net equals to 0, then the acceleration of the object equals to 0. So now if we look at the kinematic equation for the velocity of an object, see that its final velocity equals its initial velocity plus acceleration, the object, times time. So that's not a q, that's an acceleration. If the acceleration is 0, so the net force is 0, we can get rid of this, and we see that our final velocity equals our initial velocity. Now if we multiply both sides by the mass of the object, then we will get this, and we can define a quantity known as the momentum as the mass of the object times its velocity. So momentum is a vector quantity because we have a scalar times a vector. So if we look at this equation over here, we see that the final momentum is equal to the initial momentum, or we can rewrite this as the final momentum minus the initial momentum equal to 0, and final minus initial is always the change in. So this is the change in momentum. Sorry, there should not be an F there. The change in momentum is equal to 0. And then this is known as conservation of momentum. So we see if the net force is 0 in any direction, then the momentum of the object is conserved. Okay, so now what we can do is we can look at a system of particles. So say we have multiple particles, then we'll have the exact same thing. So if we have multiple particles together and the net force on them is 0, then their momentum will be conserved. So what we can say is that the net change in the total momentum of a system of particles is equal to 0, provided that the net force on that system is equal to 0. Now what we can do is we can move forward and we can look at a different kinematic equation. We're still going to have the net force of the object on the object be equal to 0, but we're going to be looking at this kinematic equation. Now, as we've said before, the acceleration will be equal to 0 because the net force is 0, so we're just left with the final velocity squared with the initial velocity squared. If we now multiply each side, if we define a quantity known as the kinetic energy as 1/2 the mass of the object times its velocity squared, then we can end up with this equation. So 1/2 v squared equals 1/2 mvi squared. We can do the exact same thing, have final minus initial squared. So now we can say that the change in kinetic energy is equal to 0 if we have a net external force. So previously the momentum is always conserved if the net force is equal to 0. However, the change in kinetic energy is only equal to 0 if a collision is elastic. So what do we mean by elastic? It means, say we have two objects coming in, and afterwards they bounce off each other, leave in opposite directions, and this is elastic because they did not stay together. Delta Ke equal to 0. And then you also have an inelastic collision where you have two objects coming in to hit each other, and after they collide, then they stick together and move off as one. And in this case, the change in kinetic energy does not equal to 0, because we lose some energy in joining these two particles together. Alright, thank you very much.